Hi and welcome to our channel. We are in lecture 5 of quadratic equations. In this lecture, we are going to discuss location of roots. In this location of roots, we are going to see total 6 cases. The first case is if both the roots are greater x naught, greater x naught. So this is the first case we are going to discuss. This is the first one. Okay. Now here we are saying that if both the roots are greater x naught. What is here x naught? X naught is a real number. So we need to compare the roots of a quadratic equation with this x naught. Here how we are comparing? Those two roots are greater x naught. Now we'll draw the graphs of this case. Okay. Now listen carefully. First of all, the graph of a quadratic equation we already know. Either it is upward parabola or it is downward parabola. Either upward parabola or downward parabola. So here what we are discussing, this is the x-axis. Both the roots means one is alpha and the other one I am taking here beta. Okay, here also if I observe this one, this is alpha and this is beta. Now we are saying that both the roots are greater some x naught. Here I am taking this is the x naught. Here I am taking this is the x naught. Here I am taking it is x naught. Okay. Now once observe here. Here also I am taking it is the x naught. Here also I am taking it is the x naught. Okay. Right. Now this is the x naught here. This is the x naught here. Now once observe here. This is x naught and alpha beta both the roots are greater x naught only. For example, if it is x naught is 1, alpha beta should be greater x naught means either it is 2, 3 or 1.5 whatever it may be. Okay. Here also it is x naught, both the roots are greater x naught only. Right side of x naught we have here. So therefore alpha comma beta both are greater x naught only. Okay. Now in this case, what are the conditions we will get? Now we are going to discuss. We are saying that both the roots are greater x naught means both roots either equal or distinct. Both the roots are either equal or distinct, but they are not imaginary, because if both the roots are imaginary or complex conjugate, we cannot compare with the real number. We'll tell you. For example, here I'm taking the false case. What is the false case graph? If you observe here, this is the false case graph. Either this one or this one. Once observe here, this is x naught and this is x naught. Okay. Now here roots are not there. How we can compare with x naught? Roots are not there. Here it is not intersecting or touching the x-axis. Roots are not there. How we can compare with the x naught? It is not possible. Therefore, the first condition is discriminant should be greater or is equals to 0. Discriminant should be greater or is equals to 0. Listen carefully. Why I am saying discriminant is greater or equal to 0? If discriminant is less than 0, we will not get two roots. We will get complex conjugate roots. We cannot compare with x naught. These roots are, if the roots are complex conjugate, how we can compare with a real number? We cannot compare. Therefore, the first condition should be discriminant should be greater or is equals to 0. Sir, how you are saying it is greater or equal to only? Why can't it is greater only? Means we can take here alpha and beta equal also. So that is this case. If you observe like this, alpha comma beta both are same. This is the x naught here. This is the x naught. Here x naught, these two are the alpha comma beta, it is equal roots. Means alpha beta both are greater x naught only and alpha beta equal. That's why here we are considering discriminant is greater or equal to 0. Depending on the question, we need to consider either greater 0 or greater or equal to 0. If the question is the roots are real and distinct, then we have to consider only discriminant greater 0. If the roots are greater some x naught, if the roots are greater some x naught, if he gives like that, then we have to consider greater or equal to also. Here it is not mentioned whether the roots are distinct or equal. It is not mentioned. Therefore, we have to consider discriminant is greater or equal to 0 depending on the question. Okay. Now, here this is the false case. So we have to eliminate. If we want to eliminate these two cases, these two false cases, we have to take discriminant is greater or equal to 0. This is the first condition. Now what is the second condition here? The second condition, here I am going to draw another false case. That is, if you observe here, if you observe, for example, this is alpha and this is beta. This is alpha and this is beta. Now I can take like this. This is x naught. This is x naught. Now, according to the first condition, if I take only the first condition, if you observe, here also we are getting two roots, alpha, beta. Two roots we are getting, means we can take here discriminant is greater or equal to 0. If I take discriminant is greater or equal to 0, this case also arises. But we need to eliminate this one. Why we need to eliminate this one? Here alpha comma beta are not greater x naught. Only beta is greater x naught. Alpha is less than x naught. Therefore, if we want to eliminate this one, okay, we need to take one more condition. That is, once observe here, this is nothing but our Vx. This is nothing but our Vx. Vx means vertex abscissa. Vertex abscissa means vertex is a point in that the abscissa is nothing but our Vx. If you observe, it is Vx and it is x naught. It is Vx and it is x naught. From these two, what we can consider, and here also if you observe, this is Vx. This is Vx and this is x naught. In these two cases, what you are observing, these two are the required cases. This is not the false graph. This is the true graph. Okay. So we have to consider these two. We have to eliminate this one and this one and this one. If I want to eliminate these three, I already eliminated these two. Now if I want to eliminate this one, I have to write one more condition. That condition is Vx is always greater x naught. If you observe these two, you will get Vx. Vx means this one. This point is always greater x naught. Vx is greater x naught. It is right side of x naught. Here also Vx is greater x naught only. So now if you observe this one, if I take here, this is x naught and this is Vx. This is Vx. Here x naught is greater Vx. X naught is greater Vx, not Vx is greater x naught. Therefore, if I want to eliminate this case, sir, why you consider this case? Means according to the first condition, discriminant is greater 0 means two roots should be there. These two are the roots. But this is the false case because here x naught is not greater x naught. Here both the roots are not greater x naught. If you observe here, both the roots are not greater x naught. Only beta is greater x naught. Alpha is less than x naught. Therefore, if I want to eliminate this case, this false graph, so what I need to consider? Vx is greater x naught I need to consider. So this is the second case. So with this, we eliminated this case also. Now, the third condition is, if you observe here, this is x naught, and what is the value of x naught we are getting here? The value of x naught we are getting positive. And what is the value of x naught here we are getting? Value of x naught here we are getting, it is negative. Now these two are the true cases. Okay, we need these two cases. We need to write the combined statement, the combined condition we need to write here. So if I want to write the combined condition, when we are getting here f of x naught is positive, this is the f of x naught, this is f of x naught, and this is f of x naught here, this is f of x naught. The combined equation we need to write here, the condition, when we are getting f of x naught is positive here, if a is greater 0, it is upward parabola, no? If it is upward parabola, definitely a is greater 0. If it is downward parabola, a is less than 0. Means if a is greater 0, we are getting f of x naught is also greater 0, means it is positive. If a is less than 0, we are getting f of x naught also negative, means the two signs are same here, means a and f of x naught sign is equal. Okay, the same sign should be there, a and f of x naught. So here also a and f of x naught same sign. So if I want to write this combined condition, what is a into f of x naught, we will get every time we will get greater 0 only. At each and every time we will get greater 0. Sometimes we will get greater or equal to 0. Equal to 0 also we will get. When if the x naught is exactly the one of the root. If f of x naught, if I substitute x naught in the quadratic equation, we will get 0. Okay, and we'll see that one while solving the problem. Okay, now a into f of x naught is always greater 0, is always greater 0. If you want, you can check. A is greater 0, f of x naught is greater 0. So the product of a into f of x naught, definitely we will get a f of x naught product, always we will get greater 0. Here also both negative means the product is positive only we will get. So this is the third condition. Okay, we need to know. So if we know these three conditions, then we can solve the problem based on this concept. Both the roots are greater some x naught. Okay, again I am repeating, once observe here. The first condition we need to take here, discriminant is greater or equal to 0, because if I want to compare roots with some x naught, root should be there. So we have to take the real roots only. We don't have to take the complex roots, because here if I want to compare, root should be there. Okay, that's why here we considered discriminant is greater or equal to 0, the first condition. And what is the second condition? So if I want to eliminate the false case, that is this case. If I want to eliminate the false case, here it is x naught and it is alpha and it is beta. Here according to the first condition, alpha comma beta, two roots are there. So according to first condition it is okay only, but this is not our required one. What we need, both roots are greater x naught we need, but here only beta is greater x naught. If I want to eliminate this case, definitely I have to consider Vx is greater x naught. Vx means here vertex abscissa. Okay, this is the vertex, and this is the vertex abscissa. Okay, now we already derived Vx is equals to minus b by 2a. This is Vx formula we already derived. Okay, Vx is equals to minus b by 2a. Okay, now this is the false case. So if I want to eliminate this one, definitely I need to compare Vx with x naught. Vx is always greater x naught. If you want, you can check. Vx is always greater x naught. Here also Vx is always greater x naught. So what is the third condition? So why we are taking a third condition means, if you observe here we are getting f of x naught is positive, here we are getting f of x naught is negative. So in order to reduce that, in order to eliminate that case, so here we considered a into f of x naught. Here a into f of x naught is always greater 0. Here also a into f of x naught is always greater 0. So this is the first one, that is both the roots are greater some x naught. Now we'll solve a problem based on this concept. Okay, the question is here, the smallest integral value of k for which both the roots of the equation, are real and distinct and have values at least 4 is. So what he is saying, for this quadratic equation we have two roots. Those two roots are at least 4. At least 4 means 4 or greater 4, he is saying. Means the graph for this equation, for this question is like this. If you observe here, if you observe the graph for this is alpha and this is beta. So here he is saying that this is x naught only, this is 4, this is 4. At least means either this case or this case. These two cases arises. This is x naught and this is x naught. He has given that x naught is 4. He has given x naught is equals to 4. This is x naught and this is alpha here and this is beta. Okay, these two cases arises. How you are saying that these two cases arises? At least 4 means the roots are 5, 6, 7 also exists, or one is 4 and the other is 5, 6, 7 or whatever it may be. Okay, this is the case here. These two cases arises. For these two cases, we already know that if you observe this one, both the roots are greater some 4 and both the roots are greater 4 or 1 may be equal to 4. Okay, so these two cases will come under both the roots are greater some x naught. What is the first condition in that? The first condition in that is discriminant is greater or equal to 0. What is the discriminant? We already know b square minus 4ac, which is equals to greater or is equals to 0. Why you are taken here greater or equal to 0? Sorry, here only we have to consider greater 0. What is the reason we have to consider greater 0? Actual condition is greater or equal to 0, but here we have to consider only greater 0. What is the reason? He has given that roots are real and distinct. Roots are real and distinct. This is very important here. Real and distinct. Distinct means we need to consider only greater 0. Okay, so don't do the mistake by taking greater or equal to 0. We have to consider only greater 0 because the question is real and distinct. Okay, and now here b square minus 4ac. B square means this is the question. Here the b is minus 8k. So minus 8k whole square, b square minus 4. A value is here 1 only, a. C value is here 16 of, c value is here 16 of k square minus k, okay, plus 1, which is greater 0. Now if I expand this one, what I will get here? 64k square minus 4 into 64 is 64. It is k square minus k plus 1 greater 0. Now if you observe, in both we have 64, take common and send that side, you will get 0. So what is the remainder here? K square minus into plus, which is minus k square, minus into minus k, which is plus k, minus into plus, which is minus 1, which is greater 0. Now plus k square and minus k square gets cancelled. So we will get here k minus 1 greater 0, which is k is greater 1. K is greater 1 means 1 to infinite. Here 1 is open bracket. For infinite we need to take open bracket. Here k belongs to 1 to infinite. This is the first condition. If I use the first condition, I will get this one. Okay. Now what is the second condition we have? What is the second condition we have? The second condition we have, Vx is greater x naught. Once observe here, this is the Vx. Okay, this is the Vx, and here also this is the Vx. Okay, we already know Vx is greater x naught. Okay, now what is Vx? We already know, which is minus b by 2a, and greater x naught is here 4. X naught is here 4. In the question it is given, it is 4. X naught is 4. Now minus b means again minus of minus 8k by 2a. A means 1 here, which is greater 4, which is greater 4. Now here minus into minus is plus, 2 ones are 2 fours are, so 4 cancel. So what I will get here? K is greater 1. In the second case also we are getting that k is greater 1. Again k belongs to 1 to infinite. K belongs to 1 to infinite. Greater 1 means 1 to infinite we can take. Here it is not equal to 0, we have to consider open bracket here. Okay. Now what is the third condition? We already know that third condition is a into f of x naught is greater 0. Here we have to consider greater or equal to 0. Why we are considering here equal to also? While we are discussing the condition in the concept, we taken only here greater 0. Why we are considering here greater or equal to means he told that at least 4 means the root may be 4 also. If root is 4, then if I substitute in the given quadratic equation, definitely I will get the value is 0. That's why here we considered here greater or equal to 0. Keep it in mind this. Okay, a value. What is a value here? A is equals to 1. 1 into f of x naught means f of 4 which is greater or equal to 0. Means f of 4 means we need to substitute 4 in this equation. This is our f of x only. This is our f of x. Okay, equation itself it is f of x. We already know. Okay, now substitute 4 in this equation, which is 4 square minus 8k into 4 plus 16 of k square minus k plus 1, which is greater or equal to 0. We have to substitute in place of x only 4. Don't substitute in place of k. We have to substitute in place of x. Here in place of x we need to substitute 4. 4 square is 16. Okay. Now if you observe here 4 square is 16. Here 8 4 is 32 means here also 16 is there. Here also 16 is there. I am taking 16 common and I am going to send that side. Okay. I will get here 4 square means 16. Here I will get 1. Okay. Here 8 4 is 32 means we already taken 16 common. 2k will be left here 2k. And 16 I have taken common, which is k square minus k plus 1 greater or equal to 0. Now here it is k square minus 3k plus 2, which is greater or equal to 0. So if I solve this one, what I will get? Roots 2 ones are 2, minus 2 minus 1. Therefore I will get k minus 1 into k minus 2, k minus 1 into k minus 2 greater or equal to 0. I will get k minus 1 into k minus 2 greater or equal to 0. I will get. Okay. Now if k minus 1 into k minus 2 greater or equal to 0, what is our condition? Means it is minus infinity to 1 union 2 to infinite. Okay. So we already know this one. By wavy curve method we can solve this one. Otherwise we already know x minus alpha into, here I am writing x minus alpha into x minus beta, which is greater or equal to 0 means the x belongs to here minus infinity to alpha. Okay, union beta to infinite. Okay, this is the condition you need to know. Otherwise you can solve by using wavy curve also. You will get this one. Okay, now we have here 3 conditions. That is the first one is k belongs to 1 to infinite, and the second one is also we got same k belongs to 1 to infinite. If I use the third condition, I got here k belongs to minus infinity to 1 closed union closed to infinite. Okay, now we need to draw all these 3 in a single real line. Okay, now if I take the real number line, single graph I need to draw here. Okay, now what are the numbers you are observing? How to draw the graph is important here. What are the numbers you are observing? Here 1 we are observing, and here also 1 we are observing. Here 1 and 2 means 1 2 we are observing, 1 2 we are observing, 1 and 2 we are observing. Okay, and we also observing here plus infinite and minus infinite. So we can take here minus infinite and we can take here plus infinite. Okay, now once observe here, what is the first condition? K belongs to 1 to infinite. 1 to infinite means from here to here, from here to here. And what is the second condition? Again it is 1 to infinite only, no need to draw. If it is same, no need to draw. And what is the third one? Third one here, if you observe, minus infinity to infinity to 1, minus infinity to 1, and 2 to infinite, 2 to infinite, from here to here. Okay, now how to write the final answer? Very important here. How to write the final answer means where the 2 lines are existed. that portion is our final answer. Okay, now where two lines are existed, we need to observe. Here only one line is only one line is there. Here only black line is there. From here to here only black line is there. From 2 to infinite, you are observing here two lines. Therefore here 2 is included and the infinite is here not included. Right, now this is the answer, but this is not the final answer, because here what he is asking, the smallest integral value of k is asking. He is asking the smallest integral value. First of all, what is the meaning of from 2 to infinite? 2, 2.1, 2.2, 2.3, 2.4, 2.45 and 3, 3.1, 3.2, 4, 5, 6, 7 up to infinite. But he is asking the smallest integral value among all those. What is the smallest integral value among all those? It is 2 itself. Okay, so this is the final answer. Okay, once observe this one. Both roots are less than x naught. This is the second case. So what are the graphs for this case? Here if you observe, this is x alpha and this is beta, and this is the x naught, and one more, that is this is alpha and this is beta, and here it is our x naught. Now once observe these two graphs. Here we are comparing, again we are comparing two roots with some real number. If I want to compare two roots with some real number, definitely here roots will exist, right? So that is the first one. What is the first condition here? Again, discriminant is greater or equal to 0 only. Discriminant is greater or equal to 0 only. We can take equal to 0 or greater 0 depending on the question. Okay, right. Now what is the second condition? Second condition, if you observe here, this is the Vx, this is the Vx, and here this is the Vx. Now once observe here, Vx is less than x naught. If you observe, x naught only greater here, not Vx greater, x naught greater. Here also x naught greater, Vx is less than. Therefore, the second case is Vx less than x naught. Vx less than x naught. And what is the third condition? What is the third condition? Here, if you observe, a is greater 0 and x naught is positive, means it is also greater 0. F of x naught is greater 0. Okay, and here a is less than 0 and f of x naught is less than 0. Again it is also negative. F of x naught, it is negative. Now if you observe, if I want to write the combined condition, so a into f of x naught, again we are getting a into f of x naught, again we are getting greater 0 only. Both are positive, means if I take the product, I will get positive. Both are negative. If I get the product, if I take the product, again I will get positive only. What is the difference between the previous one and this one? Previous one and this one. What is the difference here? Only the second condition is different here. The second condition is Vx greater x naught there. Here Vx less than x naught. The remaining everything is same. Okay. Now we'll solve the problem based on this one. The problem is here, if the roots of the equation x square minus 2ax plus a square plus a minus 3 equal to 0 are real and less than 3, then which option is correct, he is asking. Now, if the roots means the two roots are real, he is saying, and those two roots are less than 3, he is saying. Two roots are real and less than 3. What is the graph? We already know. If for example, if I take like this, here a value is greater 1, therefore it is alpha and it is beta. These two roots are less than some 3, means this is 3 we are taking here. This is our x naught. Okay. Now this is the second case, we already know. What is the first condition in this second case? That is discriminant is greater or equal to 0. Why we are not considering only greater 0? Means here he is saying that roots are real. He is not saying that roots are real and equal, real and distinct. He is not saying. He is saying real. Real means either greater 0 or equal to 0. Therefore, here we are going to consider discriminant is greater or equal to 0. Now, what is the discriminant? We already know it is b square minus 4ac greater or equal to 0. What is b here? B is here minus 2a. So, minus 2a whole square minus 4 into a value is 1 and the c value is a square plus a minus 3, which is greater or equal to 0. Now, If I simplify this one, I will get 4a square minus 4 of a square plus a minus 3, which is greater or equal to 0. If I take 4 common, if I send it to that side, I will get 0. So what we are remained here, a square minus into plus a minus into minus plus 3, which is greater or equal to 0. Plus a square minus a square cancel. Here we have minus a plus 3 greater or equal to 0. Now, if I send plus 3 to that side, what will happen? Minus 3. Minus a greater or is equals to minus 3. Now, if I multiply with minus, this inequality will become interchange. Don't cancel minus here. That is wrong. If you get here, for variable, if you get negative, we need to multiply with negative only. Don't cancel negative here. So that is wrong case. Okay. Now, if I multiply with minus, what I will get? A I will get, and this will become less than or equal to, and this will become 3. Very important. For example, if it is a less than minus a less than 3, okay, now what you need to do? Don't send this minus to this side. That is wrong. You need to multiply with minus. That is a. This will interchange and minus 3. This is the correct. Okay. Don't write like this. A is less than minus 3. This is wrong, and this is the correct one. Okay. And now similarly, we solve like that only. And what is the second condition we have? Second condition we have minus b by 2a. That is Vx is this is the Vx is less than x naught, means minus b by 2a, which is less than x naught, means here 3. Now what is minus b? Minus of minus 2a by 2a. A means 1 here. Don't confuse here. That's why it is better to take here capital B by capital A here, because in the question also a is there. Okay, that's why here we are going to consider minus b by 2a capital. B means here minus 2a, so minus of minus 2a, and 2 into a value is here 1, which is less than 3. 2 to cancel, minus into minus plus, which is a less than 3. It is a less than 3. This is the second case. Now what is the third case? Third case we already know, a into f of x naught, which is a into f of x naught is greater 0. Don't take greater or equal to 0. Why we are not considering greater or equal to 0? In the previous question we discussed their greater or equal to, because at least 4 he mentioned there. At least 4 means 4 may be the one root, but he is mentioned here definitely less than 3 only, not 3. Definitely less than 3 only. Therefore, we will not get here equal to 0. Okay. Now a value is 1, f of x naught is here 3 greater 0. Now we need to substitute 3 in this equation. 3 square is 9 minus 2a into 3, which is 6a. Okay, plus a square plus a minus 3 greater 0. Now from this what I will get here? A square minus 6a plus a, which is minus 5a, 9 minus 6, which is 9 minus 3, which is 6 plus 6, which is greater 0. Now roots we already know. Sum of the roots is 5, product of the roots is 6, means definitely it is 2 comma 3, means a minus 2 into a minus 3, which is greater 0. Okay. Now if a minus 2 into a minus 3 is greater 0, what is our answer? Minus infinity to 2 union 3 to infinite. Okay, which is a belongs to. Okay, now what is the formula for this one? X minus alpha into x minus beta greater 0. X belongs to minus infinity to alpha union beta to infinite. What is the difference between previous one and this one? Here equal symbol is there, here equal symbol is not there. That's why we have taken all our open brackets. Okay, now this is the third condition. Okay, now we need to plot all these things in a single graph. Okay, now we'll plot that one. Now what are the numbers you are observing in this? The numbers you are observing here 3, here also 3, here 2 and 3. Okay, 2, 3 you are observing, and also you are observing plus infinite and minus infinite. This is minus infinite and this is our plus infinite. Now what is the first one here? A is less than or equal to 3. A is less than or equal to 3 means, it is minus infinite to 3. Minus infinite to 3. Less than or equal to means less than 3. Less than 3 means 2, 1, 0, minus 1, minus 2 up to minus infinite. That's why minus infinite to 3. but here 3 is there, therefore we have to take here thick line. Okay, 3 is included, 3 is included. Okay, and next, what is the second one? A is less than 3. A is less than 3 means again we will get that one only. Okay, now what is the third one here? Minus infinity to 2. Minus infinity to 2 means here minus infinity to 2 means minus infinity to 2, this one, and 3 to infinite, 3 to infinite. Okay, now once observe here. If you observe here, we are having two lines, red line and black line. We don't have here black line, only red line is here. Here we have only black line, there is no red line. Now what is the final answer? Here A belongs to minus infinite to 2 open bracket. For 2 there is no closed bracket, therefore I have taken here open bracket only. Minus infinity to 2. Okay, here for 2 open bracket, in this 2 is there. Okay, okay. Now minus infinite to 2 means which option is correct? A is less than 2 only. A is less than 2. Here A belongs to minus infinite to 2 means it is A less than 2. So this is our final answer. Okay, I hope you got this one. Very simple. We have to use the 3 conditions, that is discriminant greater or equal to 0, first condition I got here, this one, and Vx is less than x0, this is the second condition. The third condition is A into f of x greater 0. This is the third condition. So if you use all these 3 conditions, you will get 3 inequalities. Those 3 inequalities you have to draw in the same graph. So after that you need to write the final answer. Okay, now this is the question based on both roots are less than x0. Okay.